Right, so this is problem number 17 in your textbook, in chapter 26. And I've got 3 capacitors that are hooked up like shown. I've got a capacitance C1, capacitor C2 on one side, and I have a capacitor C3 on the other. Okay. I know the value of all these capacitances. C1 is 5 microfarads. C2 is 3 microfarads. C3 is 8 microfarads. So to combine all of these capacitances together to get a single capacitance, I kind of need to do it in steps. There are 2 ways that I can combine capacitors. Does anybody remember what the 2 ways to combine capacitors are?
In parallel or in series?
I can combine them in series or I can combine them in parallel. And as I go down through this circuit, I can see that I have both. I come down and I reach this junction, this place where I can split. I could either go to the left or I could go to the right. So these 2, this left path and this right path, these are in parallel with each other. So I need to add whatever's in these 2 paths in parallel. Yeah? I look over here and I see C1 and C2. They are one right after another, so they're connected in series. So what I would want to do is I would simplify this circuit and combine C1 and C2 into one equivalent capacitance. And then I can add that combination with C3 in parallel to get a total final capacitance. So I'm going to see what that looks like. If I were to draw this, I would have my left side, and I'm going to figure out what the equivalent parallel capacitance is of C1 and C2. I'm going to call that C12. And then on the right-hand side, I still have my C3. So what I need to do is I need to combine C1 and C2 as capacitors in series. How do you combine capacitors in series? There are 2 ways to combine capacitors. You can add them normally, or you can add them what I like to call the flippy-flop way. Is this the normal way or the flip-flop way?
Flip-flop way.
Flip-flop way. Let's do the flip-flop way. So the flip-flop way is you have to do 1 over C12, the equivalent capacitance in series, is equal to 1 divided by C1 plus 1 divided by C2, and that'll give you your result. So I do 1 divided by C12 equals 1 divided by C1. What's C1? 5 microfarads. Plus 1 over C2. What's C2? 3 microfarads. And I can add those together. When I add those together, I get 1 divided by C12 is equal to
1 over
0.53. Type that into your calculator. Make sure that you can get that. So that should be your C12. Is that what you're getting for your 1 over C12?
Wait, can you go
There's nothing really to go over.
But 1 over...
1 divided by 5 plus 1 divided by 3 is 0.53. 1 over 5 plus 1 over 3 can't be 1 over 8. Right? To add fractions, I need to get a common denominator.
Okay.
Okay?
Yeah.
So just plug that into your
Put
calculator.
that down.
And you should get 0.53.
Okay.
Is that what the capacitance is?
No.
No, because this is the flippy-flop way. So whatever answer you get, you got to flippy-flop it. You got to take the reciprocal. To get C12, I can multiply my C12 over to the other side and then divide by my 0.53 over to the other side. That is essentially taking the reciprocal. So whatever answer you get here, raise it to the -1 power. So C12 is going to be 0.53 to the -1. I have to take the reciprocal of that to get what C12 is. And I should get 1.88. microfarads. So now my circuit diagram looks like this. I come down, I have two parallel routes, and I only have one capacitor in each one of those parallel routes, so I can just straight up add those together. When I add those together, I'm going to end up with a circuit that looks like this, and we'll call that C123. So my C123, because these capacitors are in parallel, I can just straight up add the capacitances. C123 is C12, the left side of that path, plus C3, the right side of the path. C12 is 1.88, plus C3 is 8, and I get that my total capacitance is, what is that, 9.88 microfarads. So the approach we followed there was we took the capacitances and we broke them down. We broke the circuit down step by step by step. You can do all this in one step. That's where you run into troubles. Your book kind of likes to suggest you do it in one step. I suggest breaking it up. So I do piece by piece by piece.
Do we have to draw those in our answer on the exam?
You don't have to draw those on the exam. I recommend drawing them to keep everything straight. I recommend getting good at breaking things down like this. It will become very useful in future chapters too. Okay. You're going to have to do something very similar with resistors in the next chapters. Okay. So this stuff, this is the easy stuff in physics too. This is the stuff it's more like a puzzle than anything else. Treat it like a puzzle. No calculus, all algebra. Yeah. Any questions? We don't need to convert to farads. We're fine in microfarads because all we're interested in is the capacitance. Once I start asking, what's the charge in this capacitor if I'm running 12 volts through it, then you need to be in farads. If you're actually using the capacitance to calculate something other than capacitance, put it into farads. If you're only working in capacitors, then you can keep it in microfarads, most likely. Any other questions on this one? No? No más preguntas? Bien. Let's do number 63. So somebody read for me chapter 26, number 63.
Three capacitors are connected as shown in figure 2641. Their capacitance are C1 equals 2 microfarads, C2 equals 6 microfarads, and C3 equals 8 microfarads. If a voltage of 200 volts is applied to the two free terminals, what will be the charge on each capacitor? What will be the energy in each?
Okay, so this is the picture that we have, and we know C1 is equal to 2 microfarads, C2 is equal to 6 microfarads, and C3 is equal to 8 microfarads. I'm not going to do the whole problem. I'm just going to show you how to find Q1, Q2, and Q3. You will be able to find all the energies based on that pretty easily. So I need to find the charges in each one of these capacitors. Now to do that, the process we're going to follow is the same as the process we did the last problem. We're going to simplify this circuit. We're going to combine things that look similar, that are in parallel with each other, or combine things that are in series, and break it down until it's only one capacitor. Yep. So as I come down through this capacitor, I see that I have a path that I can follow. I could go left or I could go right. If I go left, I go through C2. If I go right, I go through C3. So that's only two capacitors that are in parallel with each other. So I can combine those right away. Right? So I can combine those, and I end up with a circuit that looks like this. C23 is combined. And then I have my C1 still. So I combine the parallel capacitors. How do I combine capacitors in parallel? Do I just straight up add them, or do I flippy-flop them? Straight up add them. So C23 is just C2 plus C3. So that's 6 microfarads plus 8 microfarads. So C23 is going to be, what is that, 14? Okay, now I have my capacitors in series, C23 and C1. I need to combine those together till I get just one capacitor, right? So that will look something like, let's shrink this down, make a little bit more room. C1, 2, 3. And because these are in series with each other, I need to do the flipping, right? So I need to do C